Thanks for joining me again here at Math Rocks with Mr. Cox. This video is going to take another look at area, but in a different way from what you know in the past. So for instance, you know that if you had a rectangle, the area would be simply base times height, or if it was a triangle, it'd be base times height divided by 2. Well, what if we had other figures like regular polygons? So maybe we had a regular hexagon or a regular pentagon or a regular octagon. How would that work? And if you want to find out how that works, stick around and find out. Let's get it on! Every time that you're going to be looking at finding the area of a regular polygon, you're going to be given a different number of sides, and also you're going to be told some information. So in this case, it's a regular pentagon, so that we know that n equals 5, and we know that each side is 12 centimeters long. So if I look at this side of the pentagon, or this side, and I put a 12 in over here, that's some information here, but it doesn't totally help me find the area. So what you want to do is, and I've already gone ahead and done it here, is you want to find the center. And from there, you want to go out to each of the vertices here. And what that does is it creates 5 triangles within the pentagon that happen to be exactly the same size. So really all we need to do is find the area of one of them. And I've gone ahead and highlighted the one here at the bottom. And if we know the area of that one, all we need to do is then multiply by 5 to find the entire pentagon. So let's go ahead and do that. So I'm going to go ahead right now and I'm going to recreate that triangle down here. And that triangle, I know that the length of that side is 12, and that's really all I know so far. However, what I also know is if I went ahead and found out each of the central angles here, it creates a circle. So this one central angle here at the bottom would be right here, and that would be the equivalent of a circle is 360 degrees, and if we divide by 5 in this case, because there are 5 sides, grab your calculator and the answer is 72 degrees. So now we're getting somewhere. The next thing we need to do is we already know the base of this triangle. However, we still need to know its height. So I'm going to go ahead and draw that in here. And then what I'm going to do is I'm just going to recreate only half of the triangle. So I'm just going to pick the one on the left side. So I'm going to go ahead and recreate it right over here. And a couple things happen when I do that. First of all, we have a right angle here when we draw that height. So I now have a right triangle. I also know that this angle here is not 72 degrees anymore, it's half of that. So if I were to take 72 and divide by 2, I get 36 degrees. And I also know that this entire length here was 12, which means my bottom length here is now 6. So really all I need to do to still find the area of this triangle right here is I already know the base, I just need to know the height. So I'm going to go ahead and write h right here. And we're going to use trig to figure this out. So what we would do is, if you remember your trig, we have sine, cosine, and tangent. This is the opposite from that angle, and this is the adjacent. So that would be tangent. So I can say now that tan of 36 degrees equals, in this case, it'd be opposite over adjacent, so 6 over h. I'm going to go ahead and put that under 1. I'm going to cross multiply. So now I get h times tan 36 degrees equals 1 times 6. Well, 1 times 6 is just 6. And then what I can do is I can go ahead and divide both sides by tan 36 degrees. And if I do that, I will now be able to figure out how much the height is. So the height should be whatever 6 divided by tan 36 is. So go ahead and grab your calculator, and I already did that, and I know it's 8.26. So really now, all I need to do to find the area of this entire pentagon is simply this. I need to do this. I need to say my area of my pentagon is going to be, well, I'm going to have 5 different triangles here, all the same size. So I'm going to say 5. And I'm going to multiply that by the area of one triangle. I know that triangle down here, I have a base of 12. So I'm going to say 12. I'm going to go ahead and multiply that by the height, and we just calculated the height is 8.26. And then I'm going to either multiply it by half, or I can go ahead and divide by 2. And so grab your calculator and take 5 times 12 times 8.26 and divide by 2. And if you do that correctly, you should get 247.8. And then the only thing you need to do is add in the units. So it's in centimeters, so area is always in square units. So it'd be in square centimeters in this case. So right here, that is the area of the entire pentagon. And once again, all you need to do is find the area of a triangle, which we all know how to do already. You're just going to do some calculations and then multiply it by the number of sides. In this case, it's 5.
If you like what you've seen and heard so far, please like, comment, or subscribe. Thank you, and back to part 2.
So I've gone ahead now, and actually I have 2 different examples of what if you're not given the side. So in this case here, you're given what's called the apothem, and that's 15 meters long. And also in this case, by the way, it's a regular hexagon, so we know that the number of sides is 6. So once again, I've drawn this one triangle down here, and all 6 triangles are the same size. So later I'm going to multiply by 6. The apothem is actually the height of this triangle. I know it's kind of a fancy word, but it's nothing more than the height drawn out from the center, and makes a perpendicular angle here, or a right angle at the bottom. So therefore, we already know the height of this triangle. So once again, I'm going to take that triangle. I know my height is 15. I need to find the base. My angle will be 360 divided by 6, which is 60 degrees. I'm going to go ahead now, cut it in half. So I'm only going to look at the left side. I know my height is still 15. Half of 60 is 30. So now that angle here is 30. I've got a right triangle. I'm trying to find x. So I can say tan 30 equals x over 15. Therefore, x times 1 is x. So x ends up being 15 times tan 30, which is 8.66. Keep in mind, whatever x is, I need to double it to actually find the base, because x only goes out partially right here from one end out to the center. So I have to double it. So if I double it, I get 17.32. And at this point, you're all set. We're going to have 6 triangles. This time I'm going to go 1/2 times, in this case, I'm going to go the height next, and then times the base. So it'll be 15 times 17.32 multiplied by 1/2, and then multiplied by 6. And if you do that correctly, it'll be 779.4, and then our units was meters, so it'll be square meters. And not only is it possible that you might be given either a side or an apothem, you might be also given what's called a radius. And the radius is from the center out to one of the vertices here. And so if I recreate this one triangle, and by the way, this is a regular octagon, and I know my radius is 24 inches, would be what that triangle looks like right here. So my radius is 24. In this case, I'm going to have to do a little bit extra work. I'm going to end up needing the height and the base. So I'm going to cut it in half. I know my angle up here. If I take 360 divided by 8, because it's an octagon, I know one of my central angles is 45 degrees. If I cut 45 degrees in half, I get 22.5. So when I cut it in half, I have a right triangle. I have an angle of 22.5 degrees. And I'm trying to figure out x. And if I double it, I'll know what my base is. And I'm also trying to figure out the height. So let's go ahead and figure out x first. So you'll see over here, that's the black part. So that's going to be opposite over hypotenuse, which is sine. So sine of 22.5 degrees equals x over 24. And when you do the math on that, you'll wind up with x equals 9.18. And of course, once again, you got to double it. So if you double 2 times 9.18, you're going to get 18.36. So now we know our base. To find our height, that will be the adjacent and the hypotenuse. So that'll be cosine. Once again, do a little bit of the trig math here. You wind up with 24 times cosine 22.5 degrees, and that ends up being about 22.17. Once again, all the formula is take the number of sides, which in this case is 8, multiply it by 1/2, times our base and our height, and when you do that, you'll get 1628.16 square inches. So those are the 3 different ways that you'll be asked to find the area of a regular polygon. You might be given the radius, you might be given a side, or you might be given what's called an apothem. Hope you got a lot out of this video, and hope to see you again soon. Thanks for watching.